All right, hello. Welcome to Enrichment Lesson B, I think, of the Noisebridge Python class here at the Noisebridge Hackerspace in San Francisco, California, USA. I'm Travis Briggs. I am your instructor for today. And today we'll be covering SQL and Pandas. And mostly in contrast to each other, we're just going to blow through some of the SQL stuff. We're not teaching SQL syntax or how to write SQL queries or do things with it or set up a SQL server. We're not doing any of that. Mostly we're just showing some basic SQL in Python so that we can contrast it with Pandas, which is kind of, a lot of times easier for data analysis, like quick and dirty, or even more than that. It could just be simpler to write Python code in Pandas than to try to figure out how to get SQL to do what you want it to do. So with that, let's begin. Okay, so enrichment lesson B, and we're covering SQL. That's what I just talked about. Here's some of the things we'll do: create a database, load data, some CRUD. Then we'll talk about Pandas, loading a CSV into a data frame, inspecting data and getting summaries, filtering the data using Boolean masks. That's like a big part of the lesson. It's very important. We're going to assign new columns to the data frame. That's exciting. And then we're going to use some aggregate functions. Okay, so let's get started. So SQL is not considered to be a general purpose programming language. And as I write here, I'm sure some weirdo somewhere has been able to use it to write programs at some point. I'm sure if you go on Hacker News and search, you're going to find like Tetris written in SQL or something crazy like that. But that's not what it's for. It's for adding data to and getting data from a database. So there's different database systems like SQLite, MySQL, MariaDB, Postgres, blah, blah, blah. There's dozens, maybe hundreds of SQL systems out there, and they all work with SQL. And then when you have, so there's like a SQL standard, and then there's like slight variations and customizations of SQL. That's what's called the dialect of SQL. So you're saying like, oh, that's like SQL, but it's written in the MySQL dialect because it uses like MySQL specific keywords or something, right? We're using SQLite in this notebook because it's built into Python, and you don't need to start a server to run it, which is very nice. Because otherwise, for like MySQL, you have to like install MySQL, and then you have to like run MySQL, and you have to connect to it, and then blah, 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 blah. It's like all kind of a pain in the ass. So yeah, we're going to use SQLite, which is actually not only good enough for our purposes, but I know that people use SQLite in production, that it is fast enough and sturdy enough and whatever enough that you can just use it for your like real live applications on the web. Even, well, as long as you don't get like, as long as you're not getting like billions of users or millions of users, if you're getting like thousands of users, it's probably completely fine. That's my estimation. Anyway, Python defines the Python database API. This link goes to the PEP for Python database API, which was done in 1999. So we're going to party like it's 19. Oh my God, it was almost exactly 26 years ago when this was created. That's kind of cool. All right. And basically almost all of the database interface libraries in Python. So if you're using a library to connect to MySQL or Postgres, they all follow this Python database API. It was kind of designed as like a standard way of accessing databases, right? Because that's an application programming interface, an API, a standard way of interacting with resources. And what this means is that if your code is designed to interact with SQLite, you can then switch your database to another different database server without too much changing of your code. There will be some, but especially if you use like dialect-specific features. Though SQLite itself doesn't have, I'm not sure it has any dialect-specific features. It has definitely some certain quirks about like when you use it, but. And here's this little note. We won't be covering SQL itself in depth, which I already kind of mentioned. Okay, so SQLite databases are stored in individual files. One database per file, And inside the database, there can be multiple tables. Each table has columns, and it also has rows. So a row is a particular set of columns, so it's kind of almost exactly like the rows in the database are like rows in a spreadsheet, and the columns are the columns in the spreadsheet. So we're talking about, in this lesson, a fictional Reddit clone called Radish, which is just, I don't think that name ever even appears again in any of these lectures, but in old versions of this class, I had designs that there'd be multiple lessons about Radish, and we'd be slowly building it and blah blah blah. But like that's not what turned out to happen. So, so we're thinking about like what would the links on Radish look like? Everyone knows Reddit, right? Yes. Okay. So like it's a site, you put the links, right, and then there's comments, but we're not worried about comments or anything. We're just talking about like links, just posting links, and upvotes and downvotes and stuff. So here's a screenshot of a spreadsheet. Like here's some links, and they have like an ID, a name, URL, the date they were created, how many upvotes they have, and how many downvotes they have. So when we define this table in a SQLite database, we define what's called its schema, which like a schema is just like, what tables does the database have? What are their columns? What kind of data goes in each of the columns? What are the names of the columns? Stuff like that. It's just like the spec for the database table. So here we see the create table statement for the above table. And if I can get them both on the screen at the same time, you can see that like there's an ID column. So there's this ID row, like not row, but ID, line here. There's a name column, so there's a name line. There's a URL column, blah, 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 right? So we see how that kind of goes like that. All these syntax and keywords we're not going to cover. You can look it up if you're interested. The name of the table is links. That's important because we're going to refer to it when we add or query data. Each column has its name and its data type, like in Python where there's ints and strings and dicts and lists and all kinds of stuff. There's similar stuff in SQL. And it's used for querying and sorting. The default means that if we don't provide a value, usually it would be null, but if we give it a default, it's whatever the default is. So upvotes, default 0. Like if we haven't added any upvotes yet, then there's 0 upvotes. That makes sense. We don't want to say there's null upvotes because as we discussed with like the none type in Python, null is like none, and none is like I don't know kind of. It's like there is no value. But if we create a new link, it doesn't have an unknown number of upvotes. It has literally 0, right? So it defaults to 0. And then now I have, there's a way to do this in sfpythonlab.com. If you're in like lesson or enrichment, I don't have it. Anyway, if you're in the notebook, you can click File, Open, and it'll open a new window with a new tab with all of the stuff that's in that directory, and you can see like the other files. So what I'm saying here is that there's a file called schema.sql. So for me, I'm in VS Code, and it's right here. So this just has the create table statement that was in the notebook. If you're not really interested, you don't have to look at it. So yeah. All right, here we go. Now we get to the exciting part. Let's connect to our database using the SQLite 3 module. It's called SQLite 3 because it's version 3 and it's incompatible with the old version, so they just named it that so that you could use both if you were using the SQLite module before. Now you can use SQLite 3. But SQLite 3 has been around for like at least 20 years, so it's always going to be SQLite 3 at this point pretty much. So anyway, so we have this connect function. And all it does is return the results of SQLite3.connect. This is as the comment says, this is the file that stores our database. We can literally name it anything, just like any file. Like if you have a JPEG on your computer, you can name it foo.pdf, but it's still a JPEG, right? So here we use the extension .SQLite. It's not really standardized. It doesn't really matter, but that's what we use. It's just helpful when you look on your file system, you see radish.SQLite, and you're like, oh, that's a SQLite database, right? But it could be anything. You could do like radish.db, radish.data, whatever you want to call it. It doesn't actually matter. And when we run this code, it creates a file called radish.sqlite in the same directory as the notebook, which is helpful. And then, this is an interesting note too, just talking about stuff. SQLite supports in-memory databases, which means that there's no file. All the data is stored like in the memory of the program. But as you may or may not know about computer programs, when the program stops running, all the memory is lost, right? Like, it's confusing because people talk about computer memory. They talk about like RAM and storage, and they're both measured in like the same units of like megabytes, gigabytes. So you say like, oh, this computer has 12 gigabytes of RAM and like a terabyte of storage, like 1,000 gigabytes of storage, right? So when a computer process runs, the memory of the process is the RAM, right? And it has to, all the code is running in RAM. And if it wants to save data that will exist when the program exits, it has to write it to disk, which is the file system, which is files, which is the storage. So basically when we say SQLite supports in-memory databases, we're saying that like it supports databases that are almost like ephemeral, that they only exist while the program is running. So, and they're in RAM, which means that they're very fast, because it's like, I don't even know the numbers, but it's like 100 or 1,000 times slower, like an order of magnitude slower to read a file off the hard disk than it is to just read it from memory, right? So this is useful. I even say that in-memory databases are an order of magnitude faster than those on disk. Yeah, exactly. So if you want to store data like temporarily in a database, you don't want to just have it in like a Python list or something, you can use a SQLite in-memory database. And it's actually really useful for when you want the database to be like fresh every time the code is run. So like we're running a test, like, oh, I'm going to create a bunch of test users and I'm going to modify them somehow. And then when I'm done, I just want to throw it all away, rather than having to say like, open this file, write some data, read it back in, now delete the file. You just say like, this is only in memory, and then now it's gone. So anyway, has really nothing to do with SQL or Pandas, but it's kind of interesting. Okay, so once we've connected to the database, we say SQLite connect, and we store that as the variable DB. That's like our connection to the database. We could have also called it conn. People use sometimes, CONN. Once we've connected, we get a cursor. The cursor is the object that you use to execute all queries. So it has methods for executing SQL statements and getting back data or metadata about inserted or queried data. So this is just showing like a good way of dealing with the database cursor. So just like we use a context manager for opening and reading and writing files, no one knows does anyone know what a context manager is? I know you don't know it, but go ahead, tell me. Surprise me. Someone knows. When I say context manager, what do you think? The thing that's in the block underneath when I say context manager, I mean like obviously, right? Yeah, so it's the with as statement, right? That invokes a context manager. The context manager itself is not with as. That's not the context manager. That's the keywords that we use to invoke a context manager. But the context manager is the same thing. It's the with as. It's the same thing we use to read files that we've seen in previous lessons. If we import this closing helper, then it's just a context manager which automatically calls the .close function of whatever we called it on. So here we say with closing db.cursor, as cursor. So basically, we call this method. We put whatever it returns, wrap it with this closing helper, right? And then that whole thing becomes cursor, and then we use it. Then when we get out of this block, like we're here, like print done. Yeah, basically. So when we get here, we're done, right? The cursor is closed because the closing context manager, which is from this context lib module, right? Which kind of makes sense. Context manager stuff, context lib, okay. So I will say, I still haven't done a lesson on context managers, and I will say maybe just like file opening and closing, file reading files, you might just kind of use this as magic code for a little while and not worry too much about what's going on with it. But the point is that even if we accidentally return early or there's an exception, the cursor still gets closed, which is important because if you actually write a real program that's like reading a bunch of database files and stuff, there could be a bug in your program where you're forgetting to close the cursor, and then you're gonna like launch your startup, and then you're gonna get 1,000 users, and when you get the 1,001 user, suddenly your app starts crashing, and you're like, why is it crashing? Oh no, it's crashing, it's running out of memory, what's going on? And it's like, oh, we forgot to close a cursor somewhere, and now every time someone signs up, it's got a cursor that's not closed, so it's eating up memory in the database, you know. So what we're saying is that if we use this with as statement here, we can avoid having that happen, and your VCs will be happy. All right, any questions so far on all this stuff? Just basic SQL stuff, SQLite, how we define the table, how we connect to the database, and how we use the cursor. Any questions?
Can you go with the cursor again?
The cursor is just our interface to the database, basically. You'll see it in a second. We use the cursor to do database operations. Hold on a second. I'm worried that this guy's going to try to use the laser cutter.
Oh, no. I'm not, I have no intention to use it right now.
Okay. Okay, no, sorry about that. No, thank you.
Is it out of service right now?
No, it's just that we're having a class right now.
No,
so.
I know. Don't worry. I have no plans on noise because
Okay, thank you.
I have a quick question.
Sure.
So this context manager, is this just for SQLite or is it
No.
any database connection?
No to both.
Oh,
It's a general purpose Python feature that can be used for lots of things. Like if you look in the very first lesson, we start talking about using, where is this? White space, blah, blah, blah. Where is it? See here. Here's another one. With as. This time the context manager is the open statement, the open function. It opens the file, it gives it to you as whatever variable you want, which just could be whatever. We call it file. And then you read the file, and then when you get down here, it closes the file.
Yeah. And so, so it doesn't run in just memory, like it stays open, like when you have this connection through the context manager, right? Or with a context manager, your mean is just this with as.
Yeah. So the important part is that there's the connection, then there's the cursor. So you have one connection, and you have as many cursors as you want, but the cursors use up memory. So you want to close them when you're done.
Right.
You have one connection, as many cursors as you want. But when you do a new database operation, you basically say, give me a new cursor. And you do that with this code, which is like using a context manager. And like I said, all the context manager really does is ensure that the cursor is closed when you're done using it. And it's kind of guaranteed because if I tried to do like, if I tried to use it down here, like if I try to use the cursor here, I would get an exception. So it kind of gives you a guarantee of that, right? Because it's like, oh, if I still need the cursor, then I need to put that code inside the context, you know? Yeah. Okay. So we're going to use execute script command on this cursor to execute all the SQL commands in a file, which is mostly useful for setting up the schema. And that's what we do here. So db equals connect with closing db cursor. So we're going to automatically close the cursor when we're done with it. And now we have nested context managers, because why not? Here's another context manager. Now open this file, schema.sql, in read mode. That's what the R means. And then we say cursor execute script f.read. So there's like, again, the schema.sql file has just one schema table creation statement. But if it was like a real schema for like an application, you would probably have like a bunch of these statements for like, oh, there's a links table and a users table and a comments table and a profile table and a blah, 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 you know, like whatever. So here we open the cursor, we open the file, we read the file and take all of its data and use it as SQL statements. We execute the script, the program, the SQL that's in that file. And then when we get here, like we're outside of at this point, both context managers are closed, right? So once we finish the cursor execute script, it exits the first context manager, then it exits the second context manager. Once those contexts are exited, the file and the cursor are closed. All right, let's start inserting some data. There's also this like datalinks.csv file, which just contains a CSV of the same data that I showed you earlier as a screenshot. Now it's just in a CSV. Here's the data again in graphical format, so you can see it. It's just like a few links to very famous websites. I guess the least famous on here is probably Hacker News, right? Anyway, it's famous to me. That's all that matters. Okay, so we insert our schema, and now we can start loading it with data. Okay, so what are we going to do? We're going to use the Python CSV module, which we can use to parse the data. So this is kind of the point in the class where I start talking about like, all right, let's see. We have a CSV file, right? So let's just go over this code first. I'll leave you hanging on that. So we're saying like, same kind of setup as before with closing db cursor, with open CSV as file, as f for file. We say reader equals CSV reader f. So we'll like create a new CSV reader with that file. So basically we're reading that file as if it were a CSV, which it is. Then we can use a for loop for the reader, like for, file row in reader, print file row. Like we can just use we can iterate over the reader by itself as a for loop like this, and we'll get each line of the CSV as like a tuple, as like the first thing, the second thing, the third thing, etc. as a tuple. Here I'm using enumerate. Does anyone remember what enumerate does?
It was in the last one. I remember that.
It was in one of the previous. I don't even remember which one it's in, but I've definitely taught it in this class before.
Is it like going one by? No.
That's what a for loop does anyway, yeah.
It was in the file. I can't remember.
So enumerate returns a tuple of index and data. So here I could do like for row in reader, right? And I can print the row. Here, if I do for index row in enumerate reader, then I get the index, so 0, 1, 2, 3, 4 starts counting. And then I get the actual data as row. So this for loop and this for loop do basically the same thing, except that the enumerate function provides me with an extra piece of data, which is the index of the item that I'm at. And I immediately use that because I say skip the first row. It's the header, right? If index equals 0, does anyone remember what the continue statement does? Has anyone ever learned anything in this class?
Yes.
The continue means you just skip on, where if you didn't have continue, it would end the code right there.
You're half right. So yes, the continue statement means basically skip this one. Go on to the next item.
Oh, but
It doesn't mean that if you didn't have the continue, it would exit right there. That's break. Break is exit right now.
you also mentioned that it makes it, excuse me, it makes it hard to find errors in code with continue because it will keep going as if the error or that code wasn't there. So is it kind of like disregard this and go on?
Once again, you're half right. Yes, continue can make it hard to find errors in code, but not because it like hides the error or makes it, not, like skips it. It doesn't skip it. It just skip. I mean, it's just like it's as if it's not there, right? Like if I do like x equals 42 divided by 0 here, you can see even I don't know if you can see this on the projector. But VS Code even like grays out this code because VS Code even knows that like, hey, you put code after a continue statement, it's never going to get executed. So it's not really like skipped as much as like never even encountered. Like it'll never be encountered. It'll just never happen. But back to continue. Continuous means, yeah, you're very close. Continue means, all right, go back to the top of the for loop. Forget about the thing that we're currently on. Just go back to the top of the for loop. So what we're saying is if index is 0, if we're on the first row, continue. Because index 0, that's the first row, is all this stuff. It's the header. It's not data. Okay. And then here, I use this beautiful multi-line string, which really is probably not... I should probably reverse this. Instead of saying like, here's a new concept, the multi-line string, and you have to deal with it. I should probably say like, here is the dumb way of doing it. Like the whole string is like one big long string. And then I should later say, but really the better way of doing it is with a multi-line string. Anyway, the point of this is that you can see that all this is, the very easy way of explaining this is you can see that all of this is orange, right? So VS Code thinks that all of this from here to here is all one string. Usually you would not be able to put strings on multiple lines. If I said like greeting equals hello world, you can see the squiggles, like that's just not going to work. Actually, I didn't even show it to you here. Oops. So it says unterminated string literal, right? Like we never got to the end of the string. And you might say to Python, are you kidding? The end of the string is right here. It's on the next line. It's like, no, you can't put the end of a string on the next line. String has to be on the same line, right? Unless you're using a multi-line string, which is, notice that this starts with one quote. Most strings, actually basically every string we've encountered in this class so far has started with one quote. These strings start with 3 quotes and end with 3 quotes. And that's kind of why it's useful, because inside the multi-line string, you can actually even have quotes, right? And you don't need to escape them because it's not the end of the string until you get to the 3 quotes again. So I could say like greeting equals, if I did this as a multi-line string, I could say greeting equals hello. Like I could be maybe like sarcastic, like hello world, in air quotes, you know. I don't know why it auto-completed that. Why is this going on? All right, I do it, and it's like, and notice it didn't print hello space world. It printed hello, new line, a bunch of spaces, world, right? Like it printed exactly what's here. Because the new line and all the spaces are part of the string. So what this comment is kind of explaining is exactly that, right? Like we use the multi-line string here because it makes it a lot easier to read what's going on in this SQL statement, right? I'm doing an insert into links. Here's the columns I'm inserting. Here's the keyword values, which just means that the values I'm inserting are these, right? So with SQL, any amount of white space, remember how we talked about Python white space matters, and I mentioned that like in older programming languages and lots of programming languages, white space doesn't matter. Like in JavaScript, white space doesn't matter. C++, Java, white space doesn't matter. You can have as many spaces between keywords as you want, whatever. So in SQL, white space does not matter. So any amount of white space is fine. So it ignores all of this, and all of this, and all of this, you know, etc. So since it ignores it, we can use that to our advantage to just write this nicely formatted insert statement where we can easily read it. And the alternative, here's the alternatives. We could have it all on one line like this. Or we can have this implicit string concatenation, which is kind of ridiculous. I'm not even sure why Python has it. I think it creates more problems than it solves. But basically we have a string, immediately followed by another string, immediately followed by another string, and so on. All of those strings get added together, concatenated, into a single string. So this is like if I have, you know, x equals hello so like one string a tuple equals yes. So like here, this is just one string. It's a string, a single space, and then another string. So Python says like, oh, you ended a string, and then you immediately started another string. So I'm just going to push those together, right? This is a tuple because there's a comma here. So this is a tuple with two strings in it. In fact, you don't even need the parentheses here. It runs the same, right? Hello space world. You know what I mean? Like, and I could do like a bunch of spaces here and like I am here, you know. Now it's hello world, I am here. So all those strings get combined into one string. The implicit string, like the multi-line string, yeah, it's kind of useful. The implicit string concatenation is a good thing to know about because if you are trying to write this tuple, like let's say you were trying to say like a tuple 1, right? It's the string world, right? That's the thing at index 1. But if you did like one string, 2, so what's the thing at index 2 of one string? Nope.
No.
That's the trick question, right? It's L. It's the letter L.
Oh.
Because this is one string. So the third item is this L. If I put an X there, you'll see it. See? So if you are writing a program, So if you're writing a program and you're like, let's say you wanted to do let's say that you wanted to do like, oh, I am here, you know, but you did it the other way. You're like, L, it's supposed to be I am here. what the hell is going on? What's going on? You know? And it's like, oh, I forgot the commas between my strings. You know what I mean? Right?
Yeah. I was also going to ask earlier because on the multi-lines, like at the end of them, there weren't commas, and I was like, oh, that's interesting. You know.
On the multi-line string here.
Yeah, like there isn't a comma after links and the end of the parentheses, like we do see it in all other multi-line things. You know. Like on the right
Yeah.
side, you know, we see it sometimes.
There aren't really any other multi-line things that we're dealing with besides multi-line strings or like blocks of code, I guess. But blocks of code don't have commas because it's just like code, 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 code. So you're talking about like dictionary literal definitions?
Probably it was it was dictionaries earlier.
Yeah. Because each key and value pair in the dictionary are separated commas, and we usually put each key and value on its own line.
Mm-hmm.
So like,
Yeah.
you know, like, so we have like a dict equal, you know, Washington, you know, whatever. Like, so you don't need to put it all on separate lines, right? But sometimes we write the dictionary like this. Right? And just like, we could also write the tuple like that, right? We could write we can even put a trailing comma. Cool. All right, that's enough about string formatting, I guess. So then, this part here explains all the code up here that I kind of just explained. But basically, for each row in that CSV, we use the CSV reader to get the row, and then we insert the row into the database. Basically, we use like this magic SQL plus the row to insert the data into the database. Before I move on to this question mark stuff, which I'm definitely going to tell you about in 1 second, what I was saying earlier is like, this is the point in the class which I start to talk about like, you know, like, but T-Money, why are we like using this stupid CSV library? Can't we just use split? Like, okay, let's try this. Why does it still always want to do arithmetic error? Seriously, what is it? It's like freaking out. It really wants me to use arithmetic error. Gosh. Okay, so let's say we have like Forrest Gump, Jurassic Park. Yeah, alright, great. So we have like movies, CSV equals. And these wouldn't have spaces between them. Okay. So you're saying like, so I can do like from import CSV, CSV.reader, movies, CSV, reader equals CSV reader, movie CSV. And I do like for movie in movies. Oh, sorry, I did this wrong. Each row is a movie, right? And then we have like the release year, 1994, 1996, 1999. You can tell I grew up in the 90s. Okay, so for row in reader, print row. Nope. That didn't work. Why didn't that work? Oh, because it's a file. There's some way of doing this when you don't have a file. Okay. VS Code gave me the answer, whatever it is. Dot split new line. Okay, sure. So this is what it gives me. It gives me a bunch of lists. Forrest Gump 1994, Jurassic Park 1996, The Matrix 1999, right? Okay. So now you might say to yourself, well, why don't we just do movies CSV dot strip dot split new line and then split again. Wait, we're gonna do like for line in movies blah. Then we do like data equals line dot split comma, right? Print data. And look at, we end up with the exact same data, right? Like here's the first set of data. Forrest Gump, Jurassic Park, The Matrix, Forrest Gump, Jurassic Park, The Matrix, right? If all I have to do is split on comma, why would I import this stupid CSV library? And it's like so annoying because I have to learn how to use it and blah, 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 blah. It's like a pain in the butt, right? I'm just going to split on comma and I'll be done, right? So can anyone suggest a reason why I would use the CSV library instead of just splitting on comma? Yes, exactly. So let's say there was planes, trains, and automobiles, right? And that's, VS Code knows that it was made in 1987. I didn't know that. Okay, thanks. All right, so what do we do now, right? So now, oh crap. This is a bad example because I'm using like, I have to say, okay. I'm going to do it this way. This is not the point. Ignore all this stuff with this is just so I don't have to write a file. Okay, now we've got it. Nope. The file should be open in text mode. Okay. There's some way of doing this. The point is, you're exactly right. I can't demonstrate it right now because I don't know how to do it. I should have pre-prepared the demonstration. But that's the point. So technically a CSV file, if the data itself has a comma in it, it doesn't just blow up the CSV. You can have data with commas in CSV. What happens is you put the whole column in quotes. So it'd be quote, planes, trains, and automobiles, end quote, right? And guess what? Your code, where you're just splitting on comma, didn't account for that, right? So now you're like, okay, well now let me see, well maybe if there's too many in one row, I'll assume there was a quote, then I'll go back and then I'll do. It's like now you've created for yourself way more problems than you had if you just used the CSV library. So the moral of the story is that like, even though it seems like, oh, I can just do a quick and dirty way of doing this and it'll just work for now and it'll be fine, a lot of times it'll be more useful to find a proper library to do a proper thing the proper way, because not only do you prevent your code in the future from having errors that you are hard to find, but you just get in the habit of doing the right thing. Just get like when you're lifting weights, you get in the habit of like doing it the right way so you don't hurt yourself, right? It's the same kind of thing. Like if I'm writing a 4-line script, it probably doesn't matter, but I get in the habit like, okay, I need to read a CSV. I use the CSV library, So that's my little sermon on that. Okay, back to SQL and SQLite. So we opened the CSV, we read it with csv.reader. This is where I was having problems with that bytes.io or whatever, is that this is supposed to take a file, and I was trying to give it a string, and so it was not happy with me. There's probably like a CFZ like from string method, but I didn't really want to look it up. And then we look through every row, and then all right, so here's the execute statement. So this is the point. Ready? Notice that when we say what values to insert, we just give it 6 question marks, right? That's because there's 6 columns in our CSV, right? 1, 2, 3, 4, 5, 6, right? So each row, each of these lists that the CSV reader returns has 6 items, right? So this kind of works the same as like, if I print row right now, it prints, yeah, there we go. Okay, so it's 4 things, okay. So if I do like print this, %s, that, the other. And I do %row, not enough arguments. I thought it had 4 things. Okay, whatever. Oh, you gotta be kidding me. It looks like it has 4 things. It has 4 things. Well, does anyone know what's going wrong with this?
I wonder if it needs 5.
Maybe it needs 5, but it looked like it says len row is 4, so I don't know. No, not enough arguments for format string. So it's saying that I've got too many %s's because there's not enough arguments. There's not enough things I'm sending in. Okay. So that's problem. There we go. Oh, okay, that's why. Because this is why. This is something that I explained, and when I there. I guess I'm really off my game tonight. Sorry, guys. This is something that I explained when I explained %s strings, like %s, formatting, but that I didn't explain this time through the series because I've gotten rid of %s formatting, but it's that you have to, oh, I still messed it up. What is the problem then? Okay, anyway, this is getting so far off track, it's ridiculous. But basically, okay, let's just look at it that way. Okay, planes, trains, and automobiles, and 1987. So it printed, I gave it 4 S's, and it printed 4 things, right? And technically, there's a way that, for some reason I'm forgetting right now, to take the whole row and just do it that way, but this is giving me an error. And I thought it was like, yeah. I think it might be this. There it is. Okay, sorry. Rusty on % strings. Okay, so the point is, I'm saying here's 4 S's and here's a thing with 4 things in it, and each of the 4 things goes into an S, right? Like, right? So this is kind of the same thing here, right? I'm just saying, like, here's 6 question marks. Here's a row with 6 things in it. So replace each of the question marks with each of the things in the row in the order that they appear, right? So, if there's anything, this is the bold part of this next part. If there's anything you learn from today's lesson, if there's anything, just the only important thing about this whole lesson is that you should always, 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 forever, always, 17 always, use placeholders, question marks, to insert data into a SQL database. Why? Does anyone know why?
Is it because it's stored in memory?
No. No. Good guess though. Good guess. That's a good guess. So you could think of, we could have used string concatenation. We could have said cursor.execute, insert into links, values plus row 0 plus comma plus row 1 plus comma, right? And obviously that's uglier, but you could have done it that way, right? Or we could have done like insert into links, blah, 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 values, and we could use an F string, which is what we've been using in this course, more recently, right? And I could have done like F, row 0, and then like row 1, right? And you're probably thinking like, wow, I'm going to do it that way. That's so much easier. It's so much more obvious where the data is coming from. Blah, 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 blah. You have all these reasons why you think you want to do it that way. Never, ever, ever do it that way. Always, always, always use a placeholder. And why? Because if you do it the ways that are on the screen right now, with just like pushing strings around and smashing strings together without placeholders, without question marks, without %s, your code will be subject to SQL injection. Does anyone know what SQL injection is? Sid? What is it?
Johnny Tables.
It is, yes. That is the comic. But do you get the comic? Do you know what I mean?
You should SQL injection when they were inputting like the name.
Yeah. So these links don't explain SQL injection. Oh, this one does. But basically, yeah. Like someone can give you a string that is like, insert values row 0, and row 0 could be their username that they're signing up with, and the username could be, wait, forget all that, Control X, Control S, drop all tables, right? Little Johnny tables, right? And so this explains it. And this link.
Well, those are like malicious attacks.
They are malicious attacks, and this is the Wikipedia article with SQL injection, and then here is this beautiful article. The history of SQL injection, the hack that will never go away. Blah, blah, blah. 150,000 people had their data stolen because there was a SQL injection. The most easy way to hack, blah, blah, blah. What date do you think this article is from? Just someone guess what date this is from. November 20th, 2015. Like, this isn't like something from the 80s that we've solved now that doesn't happen, right? So, and why does it still happen? Because people come to this class, learn about SQL, and decide, no, T-Money was wrong. I'm not going to use placeholders. I'm just going to concatenate my strings. I'm just going to use an F string for inserting my database into the into the table. And then their company gets hacked, and the VCs are very unhappy. So, don't do it. So what is the one thing to learn from this lesson? Question marks. %s. Placeholders. Whatever they're called, whatever language you're using. And this applies to any language beyond Python either. PHP, JavaScript, any language you're using databases, always use placeholders to insert data. In fact, if you're using a library, and you're like, how do I use placeholders with this library? And you go to read the library documentation, and it says, oh, there's no placeholders. We just just concatenate your strings and make the string directly. Don't use that library. Like, seriously, don't use it. Okay. You don't need placeholders because, like, no, that guy's wrong. Don't use that library. Okay. Someone in this room might go on to work for like a bank, and I might have just saved like 1 million people's credit card numbers, right? Because you knew not to use string concatenation to insert data. Yeah. All right, so now we're going to get some data. Here we get the cursor again. We say select star from links, which basically means give me all the data in the links table. This is the method that's interesting, cursor.fetchAll, and then we print the data. Oops, I didn't run some of these. That's the schema. Load the data. And then when we select, Oh, and actually, you can, if you remember what I said in the last lesson that blocks don't interact with scope in general, that I can print the data outside of here, right? Like the cursor is dead when you get here, but data, that's the data I extracted from the cursor, that's still a valid variable. So I can just print that outside of the, if I tried to do like cursor dot execute describe links or something here, then I'll get an error. Cannot operate on a closed cursor. How did the cursor get closed? Does anyone know? Yes! Yes! Context manager. Someone's listening. All right, good. So here's my data. I selected all from links. I got a list of tuples. Each tuple is a row. This is kind of like the same thing I'd get back from the CSV, which actually, looking ahead a little bit, that's kind of where Pandas comes in a little bit, because it's like, all this, it's just like data in rows and columns. Like, why do we need SQL to query it? Like, CSV is very limiting. It's not memory efficient. Let's come up with a way of storing data in tables that's like efficient, easy to query, etc. And that's kind of the point of Pandas. But I'm getting ahead of myself. So fetch all returns a list. In each list, there's a tuple of values. Here's just a reminder on tuples. Does anyone remember what a tuple is?
Tuples are like lists, only you can't change tuples and you can change lists.
Perfect. That was perfectly 100% right. Yes. Tuples are immutable. So anyway, and then, yeah, so the surprising thing maybe about this is that even if I do like URL from links, I still get a list of tuples. Even though I only selected one thing from the database. The reason for that is because, let's say that I'm running a web app, right? And I'm like, okay, I call a get users method. And Paul, you're going to write the get users method for me, right? So you return me a list of tuples. Each tuple is a user, right? And then maybe someday down the line, you're in charge of the users table and you say, you know what? Users are just going to have a username, not even a password. It's just going to be a username from now on, right? So if I was looking for the username as list item, like as the item at index 0, the first item, right? And you used to return me a tuple, but now you return me a single thing, then when I get item 0, I'm going to get the letter H for this URL, right? It was just the same thing as the string concatenation versus tuple thing, right? Like, it always returns a tuple so that you can always just iterate over the thing you got back, even if there's only one thing in it. Because there's no error if you iterate over a tuple with one thing, but if you try to access one thing as a tuple, that is an error. Does that make sense? So it's like, I'm not going to go too much into this because I've been going off on tangents too much this lesson, but the point is, even if you only select one item, it returns a tuple. And see, this is the code for a tuple with one item. Open parenthesis, the string, trailing comma, close parenthesis. That's a tuple with a single item in it, if you remember that from the tuple lesson. Okay. So I'm going to start using pprint more. So here, I did fetch all. I got the name and the URL, right? Oh my god. Name and the URL, right? And now I'm saying, this will be easier if I do this. Mapping equals, oops, I wanted to preprint it. Okay, so I'm saying create a dictionary. I'm calling dictionary. Create a dictionary based on this list comprehension. The list comprehension is, remember, any list comprehension can be rewritten as a for loop. So it's for row in data. So for each row in the data, create a tuple of row 0 and row 1, right? So the first thing is the key, the second thing is the value. So for each row in the data, it created a dictionary, or it created one dictionary that for each row in the data has the key as the first thing and the value as the second thing. So it maps Amazon, Amazon.com, Bing, Bing.com, Google, right? This is kind of something I used to do in these lessons where I just kind of throw something crazy at you just to like, wow, Python can do that. That's kind of crazy. Maybe I understand some of it, whatever. It's not just all basic hand holding the whole lessons all the time, So I think I actually might be able to just do row here. I can just do that. Wow, that's pretty cool. Because the 0th item is the name and the item at index 1 is the URL. So row for row in data. Wait, if I'm just doing row for row in data, can't I just do data? Holy crap. Okay. I should explain though. Yeah, that's pretty cool. I'm going to leave that because I think it's even cooler that way. Okay, and then SQL has these things called where clauses for filtering. Basically, I want to know which links have more than 100 upvotes. Here's some code that creates a CSV with that data. So select name from, and it says where upvotes is greater than 100. So I only want rows where upvotes are greater than 100. If you're doing SQL, you can only put things in the where. This is called a where clause, like a where. It's not a statement, it's part of a statement, so it's a clause, which is like a grammatical thing. A where clause, you can only put things in the where clause that you've actually selected from the database, like upvote. So I can't say like where URL here because I didn't select URL, but I would just fix that by adding it. Anyway, so this is some code. It does the select, fetch all, blah, blah, blah. I write a name upvotes, a header row, and then I write the data. So let's see. We'll check for a second. I'm not doing any tricks. Nothing up my sleeves. What am I calling this? Output.csv. Doesn't exist, right? I run this. Here's output.csv. Name upvotes, Google 200, Bing 180, blah, 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 whatever. And they're all over 100, right? Now if I do like less than 100, now it's Amazon 70. No one really likes Amazon, I guess. Cool. See that? Cool. So like this is useful. Like I'm processing data, right? Like I'm like creating a report. If my boss says like, hey, what links have more than 100 upvotes? I can be like, oh, let me write some Python. Oh, now we know. Like, okay. And then let's say that someone created an error. Like they said the link is Google, but it's actually they gave the URL for Wikipedia. Oh, by the way, yeah, this is kind of the important point, is that it's okay to hard code the values here because this is not string concatenation. I'm not taking a variable and adding it to my string. I'm just using one literal string. Someone cannot alter this code by giving me a little Johnny Tables username or email, right? Because I'm not using their username at all. I'm just using 6 Google, blah, blah, blah. So every time I run this code, it will be 6 Google, Wikipedia, 2023, whatever, right?
But then it can't be changed because it's string, right?
Yeah, it can't be changed. It's a constant. It's a literal. Yeah. So here, the date is July 1st, 2023, which is probably when I originally wrote this lecture, right? So that it will always be that date. When you start using variables, which, can change, they're variable, then that's when you should not be concatenating, blah, blah, blah. This is just literal values here. Go ahead.
Is width essentially like the find feature? Or like in those old early 2000s PHP web, those forum pages, there was always that advanced where you can find posts, and it's find posts that only contain this thing or this sentence, and then it would only filter out those.
You mean where?
Yeah.
Okay. Yeah. Yes. Essentially, yeah. Usually, in general, Searching is more complex. Like when you're searching like for English words in documents, that's like not something you do with like straight up SQL. You kind of use far more specialized tools for that. But in general, if you said like advanced search, show me all posts from this month, right? Your forum software might write a query that says select from posts where created date is greater than after July 1st, or whatever, right? So yeah, that's kind of how you do stuff like that. Yeah, exactly. So someone made a mistake. They put Google with the Wikipedia URL. I already ran this code, so it doesn't run again, but that's fine. Don't worry about this error. So then, if someone made this mistake, I want to update it. They actually put the name Google where we wanted it to be Wikipedia. So I can run this update statement, which basically just is like cursor.execute the statement. You kind of have to understand SQL to know what this does, but it's kind of straightforward. Like update the links table, set name equals foo, where ID equals 6. So like find all the rows where the ID is 6. There's one. It's the ID, so there can only be one. And change the name to foo. So if I do that, and then how many upvotes did I give that? Oh, I didn't give it any upvotes. Okay. We could look at the code, but I'm not gonna look at the data, but I'm not gonna bother. And then I said foo here because I thought it was gonna be too obvious if I made it Wikipedia, but whatever. This is another weird thing in SQL. Like in some SQL languages you can do double equal sign. Yeah, in this you can. It might be better to do that. You also will see this regular equal sign, ID equals 6, and that means actually double equal sign. It's the same thing. It's like, in Python, equals is assignment, x equals 5 is setting x equal to 5, and x double equal 5 is does x equal 5. But in SQL, they're kind of the same. It doesn't really matter. Okay. And yeah, you can use anything in the where clause when you're updating. This isn't that exciting, but yeah, I don't know. I could say here, update, set the name Wikipedia wherever the URL, this is like a regex. It's basically saying like any URL that contains wikipedia.org. Now the name is Wikipedia. So you can select multiple things in the where clause and update all of them. That's just a SQL thing. Not too exciting. And then we could delete. Again, we delete with a where clause. If we didn't have a where clause, we would delete everything because it would match all rows. So it doesn't. So delete from links doesn't delete nothing. It deletes everything. So that's why you kind of want to always have a where clause with a delete statement. So you're saying I'm deleting this row, and then when I run it, it's great. It returns nothing. But then you might want to ask, like, did it even delete, right? Because this code ran, but if I run it again, it runs without error. Look, there's no error, right? I'm running it, right? But why? It's already deleted, so how can that not throw an error? That's just the way SQL works. If you run a statement that does nothing, it does nothing. It does not throw an error. So what you want to do, you can use this cursor.rowCount property to say like, oh, how many rows were deleted? So how many rows were deleted? 0. Cursor.rowCount equals 0. And then was deleted equals false because the row count is not greater than 0, right? So no rows were deleted, so it was already gone. There was nothing to delete. Whereas if I insert it again, which I can do by just running this line, then when I delete it again, it says 1 row was affected. True, it was deleted. So that's how you figure out, like, did I actually delete anything? Okay, it is... Oh, go ahead.
I'm curious. what's the difference between like a where clause and like it kind of sounds like I'm thinking if you're using like LinkedIn and you're trying to find like specific people and like, oh, I can really connect well with this person. What's the difference between like using a where clause to find them and using like a boolean to find them, which is
A boolean?
Yeah, a boolean.
Okay. What's the difference between using a where clause or a boolean? Well, I mean, conceptually, you don't really use either to find people on LinkedIn, right? Like, you have like an abstract concept of like, I am doing a search for something. And then there's like an interface on the website which tells you how you're able to do that search. And then that's translated into code for like how to, depending on how the data is stored, it's translated into code for like, what did the user say they were searching for? Well, that actually means that this parameter, this dimension in our database or whatever it is, right? So going back to the forum example, I'm searching for forum posts in the last month. So it does a where date created is less than 30 or whatever, right?
Yeah.
But in LinkedIn, it's so complex that it's like, I'm searching for people near me. Well, what does near me mean? It's like some concept of where your location is and this and that. It's not a where clause. It's like this complex graph of code and data, you know?
Okay.
Does that make sense?
Yeah, I'd say it definitely makes sense. It's just
Like, there's a difference between like, how would you use a where clause, which is like, oh, you put where thing I'm looking for. That's how you use a where clause. Versus, how would I build a search in LinkedIn? It's like,
okay, so
it's like a whole class by itself.
Yeah. Okay.
Okay, here's an exercise. It is approximately 8:40. We have 20 minutes, and we haven't even started Pandas. So, I think we're just going to skip the exercise. Yeah, let's just skip the exercise. You can do it on your own. Okay, let's talk about Pandas. I already talked about it a little bit. It's basically, it's not a database. It's very different from a database. It's a library for manipulating data. Pandas gets its data from somewhere else, like a CSV or a SQL database itself. So we import Pandas, and usually people do as PD for Pandas because they end up using it a lot and they want to type out all of Pandas. And now we read a CSV. This is very simple. The data is links submitted to Hacker News in July 2023, or from July 2023, just all in July 2023. I don't know. We'll figure it out. And then, so this is simple. Pandas makes this easy. You just use read CSV and give it the name of the file. So you don't have to do with blank as file. You just give it the name of the file. It figures out, oh, that's a file. I'll go look it up. I'll open it. I'll read it. I'll parse the CSV. I'll create a blah, 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 right? And what we do is we create a Pandas data frame. It's like a table in a SQL database. It's like a sheet in a spreadsheet. It's two-dimensional. It's got columns, which is like the features of the thing, and the rows, which are the things, like users with like blank, 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 you know. Cool. So we create a data frame. I'm just going to kind of blow through all of this so that we can kind of get it in. This is just an enrichment lesson anyway. It's not like essential to your mastery of the Python language. Since the CSV contains a header row, Pandas uses those headers as the index, is what it calls it, for the data frame. So if we look at, there's a header row, ID, deleted, by, time, text, dead, poll. Like a lot of this, you see these commas and comma. That's like null in a CSV, right? It's like no data, right? So you can see that I just like dumped out exactly what I got back from the API. I didn't clean the data. I didn't filter the data. Like, this is an exercise in like, here's some raw data. Work with it, you know? So, okay. It uses these column headings as the indexes, which is different from a database index in MySQL, but it's not that important. And that's just their word for it. And then we can use this df.info to get some info on the data frame, which gives us this nice a whole bunch of stuff. It tells us which columns it has. These are the indexes or labels. Some people just call them labels, I think. Then the data type. This is an int. That's an object. It's an int, object, whatever. How much memory it's using. That could be interesting if you've got millions of rows, etc. And 986 less entries from 0 to 985. Those are the indices. So that's what we have. All right, great. So we use shape, we get the number of rows and columns. So they're kind of like 2D arrays, because if we had like a data like this, data equals this, where the first item is itself a list. Like this is a list, right? I've got a square bracket. Then here's a list inside of a list, and then a list inside of a list. I mean, you could go arbitrarily deep with this, right? Like I could have a list inside of a list, 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 inside of a list. So if I had this 2D array or this list within lists, I could say like data 1, 1. And that's like the list at index 1 and the item at index 1 of that list, right? Data 1, 1. The only thing I care about is that this makes sense to people. Does this data bracket 1 make sense? Yes? Please stop me if it doesn't, because you're not going to get any of the rest of the lessons. You might as well leave now if this doesn't make sense.
X and Y values.
Basically, X and Y values, pretty row and column values. Yeah, exactly. Except that
No, it's Y.
it's like YX. Yeah. So, but yeah. And then we can get rows and columns in a data frame. iloc. So this is saying like, oh, here's like the URL column of one of item 5, right? But we can also refer to it by its index / label, which is the same thing. So like row at index 5, the URL. So this is nicer than like using just arrays with indexes and indices, right? Like we can say like, I want the URL, and this is more readable, right? We can use slice notation to select a range of rows with a specific column. So here, do we remember what this kind of means? Like 5 to 10? 5 through 10, but not including 10, right? From 5, 6, 7, 8, and 9. So 5 rows. And here we're saying get the URL for those things. And if we use head, we can look at it. So here's those URLs. Head just shows the first 5 elements or so. Exactly, first 5 elements, yeah. That's just easier than me saying like, for this, print blah. Like I just say .head, just show me whatever the top of that data is, basically. It's you'll see like Pandas is used a lot in notebooks like this one, where people are just like, wait, what about this? Well, what if it was this? Well, what about this? And they just like change the code and rerun it, and they change the code and rerun it. So having this head method is just like, oh, quick, look at some of the data at the top of the data frame, And then here I'm showing that we can use colon by itself as like to mean like everything. This is like another fruits example, apple, banana, orange, pear. If I do my fruits equals fruits and I do slice colon, then it means like everything. And it actually returns a copy of the list. So this is kind of the list copy operator in Python in some ways. Because when I appended to my fruits, it didn't change fruits because I didn't assign fruit. Like if I had done this instead, then they see now they both have cherry, right? Whereas if I do this one, then fruits does not have cherry because my fruits is a new list created by selecting every row from fruits, right? Okay. And then here I'm saying all rows with URL and title. So I get all rows with just a colon. And then I get the URL and the title. That's actually a list of columns that I want now. So now I'm getting multiple columns, right? And if I do the head, I get now URL, title, here's all of the stuff. But actually if I did like, I can't even remember how to do it. Info, yeah. Oh my god, there's so much to get through. Anyway. All rows. So you see, like, this has 986 entries. This all rows URL title, because there's 986 items in the data frame, and I'm getting their URL and title. So there's 986 URLs and 986 titles. And then if you're selecting the entire column, you can just access it like it's a dictionary, df score, which is just like, here's some scores of the first few things. That's all scores though, because I didn't supply a row range, right? That's different. Here I was calling .loc or loc or whatever, location, loc. That's why I'm calling it loc, because it's like location. Here I was calling .loc, but here I'm just saying data frame score, and it gives me just the scores. And now this is important. When I access the score column like this, I get a series object, which is different from a data frame. A series is basically a container that contains only one column. So now that I have this series, I can use the describe method to get a bunch of stuff with no effort at all. Like, how many things? There's 980. What's the mean? 63. What's the standard deviation? 121.5. You know, like, wow, here's the percentiles. That's the max. Like, this is why everyone uses this for data analysis, right? Because it's like, wow, this is one line of code. I could have just done read from CSV, get the column scores, dot describe, and now I've got the average of all the scores. 3 lines of code.
Can you access those values in your code then again?
That's a good question. I'm not sure.
Like single quote STD.
Yeah, maybe. Let's try it. Let's try mean. Standard deviation, let's try it. Oops, I pressed the wrong button. I don't know where I am. Okay. Oh yeah, you can do that. It's like, it works like a dictionary, I guess. So you do this, mean, and there it is. And like, that brings up an important point. Computer code is beautiful because it's all make-believe. So if you're wondering like, hey, will this work? Just try it and run the code and see if it works. Like, don't go looking in the documentation like, I wonder if there's a mean function on the bullet. Just try it, you know? That's why it's good to be able to like read the error messages and like understand them, because if you just try it and it says none type has no method mean, what is that? That means that, the data I'm trying to call the mean method on is none. So like, knowing what the errors mean helps you be adventurous and like bold in like trying things out, you know? Okay. And then there's max, which works as you would expect. You can call these methods directly. Oh, this is. I'm going to add this to this. So here this is slightly different in that I am calling max on the series itself. See scores.max. Here I did scores.describe slice, and this is scores.describe / mean, whatever. So, okay. In pandas, null values, which are none, null in SQL, none in Python, and they're NA in pandas. So if there's any null values in your data, you're going to convert numeric columns into floats. That's just something to keep in mind. Like, wait, these are integers. No, because one of them was empty, so now they're all floats. That's all it is. Okay. And now we're just going to try something with some data that we can look at more clearly before we get back to the Hacker News data. So here we have a data frame with a name column and a price column. And you can add 10 cents to the price directly. So if I do like fruits data frame, price, plus equals 0.1, it adds 10 cents to every price. Like, it's just like super easy, super fluent. If you know what I mean by fluent, it's just like readable, it's understandable. It's like, hey, add 10 cents to every price. In SQL, this would be like update fruits, set price equals price plus 1, like. So what's more readable, this or this, right? Cool. And then I wanted to point out that this is not valid Python syntax in general. You can't always plus equal 1 to something, Like, if I have this list of numbers and I try to add 100 to all of them, this is not going to work. Can only concatenate list to list. And this is back to understanding what the error messages mean, right? Concatenate, what does concatenate mean? The plus operator is often used to concatenate things, like a string and a string, you concatenate them. You don't actually add them, right? So here it's saying, I can only add another list to a list, right? Numbers plus numbers. But I can't add the number 100 to a list. It's like, but T-Money, isn't that what I did right up here? And I'm like, yeah, exactly. Like, Pandas does special stuff with Python internal methods so that something like this works. It will not work for normal lists. Pandas overloads, so to speak, the addition operator. Plus minus, division, times, modulus, and shortcuts like plus equal, times equal all work for Pandas data frames. So then I can assign new values. So I'm saying like row 1, set the price to 69 cents. And then here, if I want to add a new row, data frames, they have the same, if you want to add a row to a data frame, you have to create a new data frame and concatenate them together. That might not be true. That's just the way I found to do it. I should research that more. But basically I added like a grape column. This is so messy. This can't be the way to do it. But this is the easy thing. This has to be wrong. I'm pretty sure this is wrong. Anyway, but this fruits data frame on sale, false, true, false, false. That is the right way of doing it. I'm saying like, hey, there's a new column and it equals this, and it just puts that column in, right? Yeah. Okay, we are at time. I actually have an appointment after this, so we have to quit there. There's a cool thing about Boolean maths and then answering questions about the data, but eventually we get to, can I do this? Yes. Okay. And it's like, what day of the week has the highest scores? This is kind of like the questions we answer about the data. What's the maximum score on day 9, etc. there's this cool thing. This cool thing here where we like put basically like month and day columns on the data, so that we can say like, what day of the month has the most submissions or whatever, right? Just and we see that we can answer these questions kind of simply by just saying like, the data frame where the day equals 9, take the score and take the max. So what was the max score on day 9, or the 9th of July, right? So this is the kind of stuff I explained this further in the Boolean mass section. But this is the kind of stuff that Pandas lets you do, where this would be like, in SQL, this would be like select, whatever, max. But that's not it. Like, max score from data. Yeah, it would be something like that. Yeah. Word data frame. Yeah. Anyway. Okay, that's it. Any last questions before we go? I know today was very... I feel like I was fumbling through this one. I should have been more prepared. I'm sorry.
I learned a lot about
Yeah.
SQL.
Okay, I'm glad.
For SQL.
SQL, yeah. SQL, people say both.